But here the story changes a little bit. Now what they're asking is, let me pull up the Excel sheet. Right. So in here you will be given an array of numbers like this. They are not necessarily be in any order. For example, it could be like 5 and 7 and maybe something like 3 and something like 44, 91, and then it could be 12 and like -1 and maybe something like -17, right? Now what they are asking is, you need to find out in the given array the longest increasing subarray. Longest increasing subarray means if you take 5 and 7, the length of this array is 2, right? There are 2 elements and all these 2 elements are increasing. See, first we have 5 and then 7. So if you count them from left to right, it is increasing, right? But 3 is kind of breaking that sequence, because after 5 and 7, if it has to continue that increasing nature, there should be something that is greater than 7 here, right? Not 3. 3 is less than 7. So here you can say the chain is broken. But by breaking the chain, actually 3 started a new chain. See, 3, 44, 91. Now you can consider this as a new chain, right? But if you look at the length of this increasing sequence, it's actually 3, right? So far the increasing sequence length you found is 2. But now the increasing sequence length you found is 3. So what is the max so far? 3. Now it seems like 12 breaks this sequence, right? So now if you start counting from 12, actually 12 and -1, they are not increasing, they are decreasing. And -1 to -17 also decreasing. So for this particular array, what is the answer? 3. Then how to solve this problem? See, to solve this problem, you have to use the exact same approach we used yesterday. We will be counting what is max subsequence or max subarray, and at the same time, we will be counting what is the length of current subarray, right? Current subarray. So initially, max subarray starts with 0, but current subarray starts with 1. Now, why am I starting this one? See, if you consider an individual element, it will be treated as increasing. That is what this second test case tells us, right? So look at the second test case in this program. In this program, in the second test case, there is no increasing subsequence. All of them are 2's, right? So no 2 is greater than its previous 2, right? That is why there is at least one longest continuous subsequence that is increasing, a length 1, and this is only 2. See? So you can consider a single element as longest increasing subsequence 2, according to this question. So at any given point, you can be very sure that at least there will be one element in the current subsequence. And for that matter, you can also start maximum subsequence also from 1. Right? Now see, now the idea is we try to run the loop on the array, not from 0th index, from first index, like this here. And every time I try to check if the increasing nature of the subsequence is maintained. How can I check that? See, if the increasing nature of the subsequence has to be maintained, the current value you found, like 7, this one, it should be greater than the previous value, right? Like I-1. So value at ith index must be greater than value at I-1. If that is true, now we found 2 values, right? Like the length of 2 subsequence, which is following this property. So you're going to increment the current subsequence length to 2. Now I will move on this I. So with I-1 also moves, right? Like this. Now see, I value is 3, right? But I-1 is 7. So simply array of I is not greater than array of I-1. So what does that mean? That means the increasing sequence chain is broken here. Now what I will try to do is, so far whatever the current subsequence I accumulated, I will try to update max subsequence with the current subsequence and the max. So currently out of 1 and 2, 2 is max, right? So I'm going to update this with 2, because I found 2 values, a length of 2, where the numbers are increasing. And then from now onwards, I have to start counting from 1 again. I will set current subsequence to 1. That's it. So this is what we exactly do yesterday, right? So just recall this. Yesterday, when you kept on finding zeros or when you kept on finding ones, you started incrementing the ones count, right? But whenever you encounter a zero, you stopped and you updated the max ones count with the current ones count and whatever that is present in max so far, right? The max of that. So here also we're using the same strategy, right? So let's continue this. So here current subsequence started from 1 again and we moved I to the next index. Now see, array of I 44 is greater than array of I minus 1, right? So what do we do in this case? We will increment current subsequence value by 2 and move on. Simple. Just like in this yesterday's example, whenever you found 1, you are incrementing ones count and moving forward, right? Here also, whenever you found ith index value is strictly greater than I minus 1 index, then you are incrementing current subsequence length, right? Yes. Can you hear me? Is my voice audible? Hello? Can you please put the message in the chat box if my voice is audible or not? Is it audible? Okay. Okay. So let us continue. So here 91 is greater than 44. That means we are going to increment the current subsequence value one more time by making this as 3. But now when I moved my I value to 12 here, you can see 12 is not greater than 91, which means the increasing sequence is broken here. So that indicates now we have to update the max sub value with the maximum of whatever that is there in this max sub 2 and also the maximum of current sub. So what is the maximum? 3, right? So we are updating with the 3 and we are setting the current sub back to 1, right? And simply start counting again. 12, and if you just move here, minus 1 is not greater than 12. So that breaks the sequence here itself. But if you can observe here, current sub value is not greater than max sub, right? We only update it when current sub is greater than max sub. So we don't need to update. And in the next iteration also, we don't need to update because minus 17 is less than minus 1. So finally, when you come out of this loop, because you visited all the elements, you can see max sub is 3, right? So let me try and implement this in code. Let me write the code for this. So here I'm trying to write it in C++. And in C++, first I need to take 2 variables. One, to keep the count of max subsequence. You can start it from 1 because at least there will be 1 element. That's what they mentioned. Or you can start from 0 also. And then I'm trying to find out the current sub value. So what is the length of current subsequence? Starts from 1, right? Now I will try to run the loop from not 0, rather 1, and I less than nums.size. If you are using C++, vector size can be found using the size variable, the size method I++. Now, when I will keep on incrementing the current sub count, I can increment this as long as current value I found, which is nums of I, is greater than nums of I minus 1, right? See, it's only logical, guys. If you want to keep the nature of increasing, you have to make sure the current value is definitely greater than its previous. The current value is I. Previous value would be at I minus 1 index, right? In that case, I'm going to simply current sub plus. Otherwise, right, when the chain is broken, you are going to update max sub with the maximum value. Max is a function that is present in C++, which is used to find the max of 2 values. existing max of value and current sub value. Whichever the one is max, we are going to update max sub with that. Not only this, we need to set the current sub back to where it is started, here, 1. Okay. So finally, we are going to return max sub and current sub. Now that is going to solve this problem. Did I spell it wrong? Yeah, 3 R's are there. Let me remove 1 R. Right? So both test cases passed. How many of you understood this logic? So did you understand this code we have written? What is happening in this? So this is similar to yesterday's code only, that forms max consecutive ones. Okay, so I hope this is clear. So before making any progress from this point, I would like to ensure that you know everything about strings also. So can you comment in the chat box if you know the basic operations on strings in the language of your choice? If you are a Python guy, you just need to know how strings work in Python. If you are a C++ guy, you just need to know how strings work in C++. And the same goes for Java. So if you have the knowledge of strings, message in the chat box, yes, I do. So because from now onwards, I just want to concentrate on any problem, and most problems revolve around arrays and strings only. Guys, I'm expecting some responses from you. So how many of you are familiar with the concept of strings in your language? So when I say the concept, you don't need to learn the deep concepts. It's just how a string works, and a character in a string is nothing but an ASCII code point value. Like it contains ASCII values, small a and capital, small a to small z ASCII values like this. So how many of you know these concepts? So you just have to know it in your language. So you can message in the chat box that you do. No? So we need an explanation on strings too. Okay. This is hard to explain because in one language it works in some way, and in another language it works in another way. Anyways, I will try to do this. Okay. Guys are attending intermediate sessions, and one would expect you to have knowledge on strings. So really you don't have knowledge on strings, anybody? Or you can't hear me or something? Okay, so anyways, in any language, a string behaves just like an array despite some changes. For example, if you take an array in any language, like it could be C, C++, Java, or Python. In Python, we call it as a list, of course. Mostly arrays are mutable. Mutable means if you create an array of 5 numbers like this, or maybe 6 numbers like this, it is indexed, which means it contains indexes. You can access the elements using indexes. Apart from that, if you name this array as A, it's open for changes. Open for changes means currently 4th index is occupied by 50, right? Like this. But if you try to change this 50 to 100, it works perfectly. You can just come and write a of 4 equals 100. Now that means you are trying to change the fourth index value from 50 to 100. Now this works, and now your array contains 10, 20, 30, 40, 100 and 60. Now this kind of nature, this kind of nature is called as mutability, right? This is a word that is used in programming a lot. Mutability means even after creation, you are able to make changes to the existing array, right? But when it comes to strings in languages like Python and Java, strings are immutable, right? Strings are immutable, which means if you create a string like this, the same array version I am writing, ADI, TEYA, Aditya, then once you created the string, you have the ability to access you will have the option to access the contents. Like if you call the string as yes, you can write s of 0 in Python, or in Java, you can write s dot caret. This is the method you have to write in Java, caret of a particular index like this 0 to access this a, right? But the problem is you will not be able to change this through these methods. So in Java and Python, strings are immutable, right? You can access them, you can try to run a loop on them, but you can't simply change their contents once it's created. Now, for this reason, both languages offer a way around. What is that way around? Well, the way around is you can try to convert a string into a list, convert a string into a list in Python, and then you can make changes. And in Java, you can convert the string into a character array. And on character array, you can make changes in Java. But on a contrast with Java and Python, in C++, strings are actually mutable, right? In CPP, strings are mutable, which means you can create a string and you can also change its content, right? So basically, strings are nothing but arrays, but strings are going to contain characters in the place of normal numbers like this. So it's a collection of characters only. They are also indexed. You can access the contents using indexes, but if it is C++ or Python, you need to directly use the operator s of 0. Like you can use the same syntax you are using for arrays using the square brackets. If you are using Java, you need to use the string name dot caret method to get a character at an index, right? And I also hope you guys know that characters are ASCII code point values in programming languages. See, in programming languages, basically, if you take A to Z characters, they were assigned with the numbers 97 to 122. Now, this kind of numeric representation of numbers is a part of ASCII character set, right? ASCII character set. And we try to call these numbers associated with the characters as ASCII code point values. For example, every character you see, it could be a hash symbol, or it could be an @, or it could be a question, or an exclamation mark, or a question mark, contains one numeric value attached to this in this character set, right? For example, small a's ASCII value is 97, small b is 98, small c is 99, and so on and so forth, right? And so on and so forth. Small z ASCII value is 120. So I hope you know about ASCII, guys. How many of you know? Like, can you tell me what are the ASCII code point values of capital letters? So for small letters, the range is 97 to 122. So what is the range for capital letters? You have any idea on it? Yeah, almost correct. It's a 65 to
ఉంది బాగలేదు.
That's correct. It is 65 to 90. Yeah, you can count them. There will be 26 values from 65 to 90, and there are 26 alphabets, right? Okay. So I will try to show you the basic example of string programs in all the three languages. Then we can just move on. Right. So first, let me show it in Python. String example.py. Now, first I will show you the programs in such way that I will create the string directly in the program. So in any language, if you would like to create a string on your own, string literal, you can simply write double quotes, and inside the double quotes, you can write whatever you want. Here I am writing something like hello world. Now this one is called as a string, and it is containing how many characters? It is containing not 10 characters, rather 11. Because in strings, the spaces also count, right? Hello is 5 characters long, world is 5 characters long, and space adds up to 11, right? So now you have to store this inside a variable, let's say s, and simply in Python you can print yes. Now this is how you can create a string and you can print, right? So let me run this, and you can see hello world printed, right? Now as you can see, this string is nothing but a collection of characters, which means every single character has an index here, right? Just like array, H is at 0th index, E is at first index, L is at second, another L is at third, fourth, and so on and so forth, right? So if you would like to access any character, just like think of it accessing a number, simply write s of 0. S of 0 is going to give you H, that is 0th index character, right? And if you want to access this O, you need to write 0, 1, 2, 3, 4, right? So if you write s of 4, you are going to get O printed like this. So let me run this. So H and O. Now when you create a string, the obvious question comes into the mind that how can I find how many characters are present in this string, right? Almost all languages offer a method or a function to find this out. In Python, you can find that using length function, right? Length function used to find the length of an iterable. Iterable means it could be a string or it could be a list. So simply you just need to write length of string name. Now how many characters we thought? 14 characters, sorry, 11 characters, right? 11 will be printed on the screen. Let me run this. So you can see 11 printed on screen. Now, one more obvious question comes into the picture is, how can I access the characters of this string one after the other? Well, just like you access the characters of array by generating the indexes, you can access the characters of string also. Simply write a for loop for I in range of length of s. So what we are trying to do, we are trying to generate the indexes from 0 to last index. In this case, last index is 10, right? Now, if you pass length of s is 11, right? Now that means this range function generates the numbers from 0 to 10. So that's what we exactly need to access all the characters, right? For example, if I try to print I, see what will be the output. See the output here is, see, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Like this, you can run an index-based loop to generate the indexes, and using indexes, you can access the value like this. S of I. Now S of I means you're accessing S of 0, that means H. S of 1, that means E, and so on and so forth, right? So let me run this. And when I run this, you can see we accessed all the characters. H first, E, L, L, O, like this. So like this, you can run an index-based loop. And also, if you want, you can run a value-based loop. So this is index-based loop on strings. And you can also run a value-based loop. And a value-based loop is even simpler. You just need to write for each char. This variable name is up to you. You can also write it as I. For each char in S, simply print each char. Now this is also equivalent of running a value-based loop on arrays. Nothing changes, right? So let me run this, and you can see hello world is printed 2 times. First time as a result of index-based loop, next time as a variables, right? Now, as I mentioned, every character that you are seeing here has an ASCII code point value. In Python, if you want to see what is the ASCII code point value of a character, you can, I'm commenting this out for the moment, you can simply run the loop like this, each char in S. While you have the character, you can send it to a function called OR, right? So you can simply write each char and also ORD of each char. See, ORD function is responsible for taking the character and generating its ASCII code point values. For example, if the character is A, small a, then it's going to get you the ASCII code point value of small a, which is nothing but 97, right? And if the character is capital Z, it's going to get you the ASCII code point value. ORD function's work is to get the ASCII code point value of Z, which is 90. Like this, you can use ORD function to get the ASCII code point value. Now, this one is required in Python, but in Java and C++, implicitly, a character will be treated as ASCII value only, right? You can directly typecast it to an integer and you can try to print it. I will show you that in a moment. First, let me run this code and show you printing the character and ASCII value also. So I'm running this code. See, the characters are here. H is 104, its ASCII value. E is 101, L is 108, another L is also 108, 111, 119, 111, and so on. Is it clear, everyone? How many of you understood the basics of string? And in Python, if you want to read the string, instead of taking the string like this from user, you can simply read the string by writing s equals input. That's it. So input function takes the input as a string only. So now whatever the code I have written now works on a given string. So we are not restricted with a static string like this. You can simply run this code to take whatever the string you want. So here I'm taking a string on my own. Like I'm giving the string, I love Python programming language. And you can see the given string is printed and the characters at first index and zeroth index and fourth index are printed. And length of string is 135 characters. I is 105 and space is 32 ASCII value. L is 108, O is 111 and so on. Is it clear, guys? You guys already know about strings, right? I guess I'm just wasting my time. So how many of you would like to see the same kind of programming Java and C++? Or should I just continue with some problems directly? See, if you want to see how the same thing can be achieved, like how to read the strings, how to access them using index and value based loops in other two programming languages, comment out, I want to see. Otherwise, I will just move on with programs directly. I hope you know how to handle strings, because if you know arrays, as far as the looping is concerned, strings is also same. Clear? So nobody needs an explanation. Okay, so if you don't need explanation in your language like C++ or Java, so I'm moving on by giving directly a problem to you. So this is one very basic problem on strings. So I'm sending its link in the group, in the chat box, not group, of course. So solve this and send the screenshot. Okay, that program is all about the ASCII values I just described. So this program asks you to find out the score of the string. You just open the problem and read what score of the string is. So So you can open the chat box and you can find the question, or you can directly open 3110 from link from lead code.
తిను. Love you, बच्चा.
Okay guys, so as you can see from the description in this program, it is asking that you are given a string S. The score of the string is defined as the sum of absolute differences between ASCII values of adjacent characters. So adjacent characters means right next to each other, right? So what is the score of hello? The score of hello is defined as the ASCII code point value difference of HE, its sum, and EL, the difference, you have to add this, and LL, you have to add the difference to sum, and LO. So these are the consecutive characters, right? So you can see H is 104, E is 101, L is 108, O is 111. So first we are subtracting H and E, and the difference is 3, right? And this one is 7, and the other one is 0, and the next one is 3. So 3 plus 7 plus 0 plus 3 is 13. Now, as I mentioned, in Python, if you have to solve this, you need to make sure you find out the order. Order means the ASCII code point value using ORD method. But if it is Java or C++, they have the ability to implicitly treat the H as 104 only, right? So you can simply perform absolute values of 104 and this 101, their difference, and you can add it to sum. So first let me solve it in C++. We are given a string here. See, we need to find out the difference between consecutive values, right? That means adjacent values. So here you cannot simply go to the last index, right? Because if you go till the last index, there won't be any next value, adjacent value for this on right? So that's why I'm going to run the loop like this. I equals 0, I less than s dot size minus 1. So if it is C++, you can use the size. This is a method that is present on strings, and using this method you can find the length of the string, how many characters are there, right? So why am I not reaching the last index? I'm reaching the last index but 1. The reason is, for last index but 1, for this L, there is an adjacent O here, right, on the right. But if I reach O, there is no adjacent character for O on the right side. So that is going to give me a index out of bounds error, right? So that's why I'm stopping at last index minus 1, right? Now, all you need to do is just access the element at current index minus access the element at the next index, which means if as I is at 0th index, I'm accessing this H and then I'm accessing this E. Now you may wonder, sir, how can you subtract two characters? For example, if these two are numbers, it makes sense. For instance, in the place of this H, if there is something like 100, and in the place of this E, if there is something like 200, making the subtraction makes sense. But that's the point here, guys. In C++ and Java, the character itself will be treated as its ASCII value. For example, if you imagine this S of I is H, and I plus 1 is E. So basically, subtracting H and E is nothing but subtracting ASCII value of H minus ASCII value of E, like this, right? So that is why it is completely valid in languages like C, C++, and Python, right? Now we need to find its absolute value because we don't know which one is smaller or which one is greater, right? Sometimes this can be H, this can be E. In this case, you get positive value only. But sometimes this can be E and this can be H, right? So for that, we are using ABS, and we want to add it to a variable called sum, right? Sum equals 0, and let's write sum plus equals to this value. And finally, return sum. So let's see if this works or not, right? See, accepted. Now that is how you try to approach this string problem. So first, we are not going till the last index because we are always accessing I and I plus 1, and there won't be I plus 1 for last character, right? That's why we are going to last index minus 1. And as I mentioned, S of I here, you have to imagine if this is something like B, you have to imagine 98. That is its ASCII value, right? Right? If S of I plus 1 is something like Z, you should not imagine Z here. Instead, you have to imagine something like 120. Now that's going to give you a difference of, let's say 24. And we are adding this 24 to sum, right? So I hope you understood how this is working. Cool. So since this is the first program on strings I'm showing, I will write the code in other languages too. So in Java also, we try to do the same thing. but it slightly differs in terms of the methods we use. For instance, in Java, you run the same loop, it doesn't change. Int I equals 0, I less than, but it's not size. This time in Java, you have to write length, right? This is the method to get the length of the string, -1, I plus plus, and the remaining story stays the same. You can take a sum variable and set it to 0, and you can simply write sum plus equals to, instead of writing s of I, here you have to write s dot caret of I. Okay, so in order to access an element or a character from a string in Java, you cannot simply write s of I like you did in C++ or Python. This is the limitation. In Java, string is an object, and you can only access a character through a method called caret of I. I'm subtracting this character from s dot caret of its next character I plus 1. So next characters means not in alphabets, but in this string. Okay, and also in order to use ABS, you have to use math.abs in Java, because ABS is a function or a method that is present in math class. Okay, so finally you can return sum. Right, so you can see in Java also it is accepted. I will show it in Python also. So in Python, you need to write like this. So same, you are going to take a sum, and you're going to run the loop like this for I in range of length of s minus 1. I already showed in Python, right? In Python, if you want to find out the length of the string, you need to use the length function. And as I mentioned a couple of times, we are only going till the last but one index, not last index, because for last index, there won't be any adjacent character on right. Okay, so simply write s plus equals, but here for each character you access, you need to get its ASCII value. So they are not implicit like they are in Java and Python, Java and C++. Here you need to use a function called ORD to get its ASCII value. For example, if s of I is something like h, you need to use ORD function to get the ASCII value of h. Okay, that is why I'm writing ORD of s of I subtracted with ORD of s of I plus 1. I plus 1 is the adjacent character. Okay, and an absolute value of this. So I'm using ABS again and return yes. That's how you solve it in Python. So when I run this, I in range of here the string name is yes, and I also have taken this value as yes. That is why it is giving me error. So here I'm taking this as su and su plus and return su. Okay, so the name conflict happened here. Okay, fast. Is it clear, everyone? How to work with strings? So did you understand how did we find the score of the string? Okay, so my suggestion is, if your string knowledge is rusty, when I say string knowledge, I actually mean the basic knowledge like what are ASCII values and how can you identify whether a character is alphabet or a number, or how can you identify whether a character is uppercase alphabet or lowercase alphabet. If you lack these kind of knowledge, so before coming to the next classes, I hope you just revise the concept of strings in the language of your choice and come. Right, those are very essential. And also learn about a couple of methods in the language you use about strings. Like if you use Python, just see what are the string methods available to perform different string operations, and the same goes for Java. Right, so I just would like to ensure that you understand strings to some extent. So I will try to give one more problem on strings, which is very easy to implement. Try to solve that one also in the session today. Okay guys, open that problem on string and try to submit in your language.
ఆ రూమ్కి వెళ్ళిపోవచ్చు తమ్ముడు.
Okay, guys, we will see more string problems tomorrow. So the session is over for today. You can leave. Okay, and recollect your string knowledge. Okay, sir, 1 minute. Sir.